Hello, hello, and welcome to a little video about that quiz review. Oop, there goes that bell. Okay, all right, let's get started. So the first thing that I want to review is calculating the average rate of change based on a graph. The way we do that is we begin by plotting 2 points at perfect little corners. So, well, maybe I shouldn't use a black pen on a black graph. How about a yellow pen? All right. Okay, so here's a perfect point, here's another perfect point. We're always going to go from the left point to the right point. So let's find our rise over run. Well, it looks like I go up 1 block and over 1. So 1 over 1 is my average rate of change for this one. Let's take a look at letter B. In letter B, here's a perfect point and here's another perfect point. Once again, I'm going to do rise over run from my left to my right point. Okay, so this time it looks like I'm going down. So I'm going down 2 spaces, and I'm going to make that a -2 for my rise to say that we're going down. And then I'm going to the right 1. So -2 over 1 is that average rate of change. Now let's do the same thing, but at a table. So here is a table with a couple of typos, but there they are, a little fixed up right here. This is the formula to finding average rate of change. So I'm going to take y2 minus y1, x2, and minus x1. So on the top, so I labeled x1, y1, x2, y2 on my table. Now I'm going to go ahead and plug in values. My y2 is -14 minus my y1, which is -12. x2 is 9, x1 is 7. 14 minus -12 is -2. 9 minus 7 is +2, which I can reduce to -1 over 1. Let's do the same thing for letter B. I labeled x1, y1, x2, y2. On top of my fraction, I do y2, so that's 19, minus y1, which is 17. I don't know why I wrote 19 again. And then on the bottom, we have x2, -1, minus x1, which is -2. 19 minus 17 is 2. 1 minus -2 is +1. Number 3. A flower is currently 3 inches tall and grows 6 inches per year. Let's model this scenario with the arithmetic sequence in explicit form. I'm going to zoom in just so my handwriting is a little better. There we go. Okay, so this is the sequence, the arithmetic sequence, explicit form. Let's plug in our values. So we have a(n) equals. A1 is our beginning, so our flower starts at 3 inches. D is our common difference, our average rate of change, our pattern, 6 inches per year. That's it for letter A. Letter B. I want to rewrite the explicit form in function notation. So I'm going to take the the explicit form that I just wrote and copy it, but with x's and function notation. So instead of a sub n, I have f of x. Instead of n minus 1, I have x minus 1. All right. Now, let's simplify this. I have a 6 in front of parentheses, which means I've got to distribute that 6. Well, the 3 stays as it is because there's nothing in front of it. 6 times x gives us 6x. 6 times -1, -6. The last step I have here is combining some like terms. This 3 and this -6 both do not have x's, so I can combine them. So I am left with 6x minus 3. Letter C asks us to determine the height of the plant after 4 years, which means we're going to plug a 4 into f of x. Our function is 6x minus 3, so this time I'm going to do 6 times 4 minus 3, because we're asking for 4 years. So 6 times 4 is 24. So 21 inches after 4 years. Let's do the same thing for number 4. During a road trip, a car is traveling 55. Oh, the car is 55 miles away from home and travels 60 miles an hour. Let's model the scenario with an arithmetic sequence. So a sub n equals, our first term is 55, plus our common difference 60, our pattern, times n minus 1. In letter B, we're going to rewrite that same equation as a function and simplify it. So let's do that. Okay, so like the previous problem, we're going to have to do some distributing. And we distribute through multiplication. All right, so the 55 stays 55 because there's nothing next to it. 60 times x gives us 60x. 60 times negative 1 gives us negative 60. 60x has nothing to combine with, so it stays 60x. But I do have like terms. I have this 55 and this minus 60 to give us a negative 5. Notice how I say a negative and minus interchangeably, and that's because negative and a minus sign are technically the same thing. Letter C, determine the distance after 5 hours. Well, let's do that. We're going to plug a 5 into our function. So instead of 60 times x, we have 60 times 5. Minus 5. I think that's 300. Threes aren't looking that nice today. 300 minus 5. So they've traveled 295 miles. Number 5 asks us to transform some linear functions. So in letter 5a, we have the graph 4x minus 4 already graphed in green. What we're going to do is graph f of x plus 4. So luckily for us, we do have f of x. F of x is our original function, 4x minus 4. And then I'm going to add a plus 4 at the end. I'm going to combine like terms. Minus 4 plus 4 gives us 0. Now I know it's incredibly silly to write plus 0, but I promise it's useful. So just some color coding so you know where I'm getting that f of x from. The 0 tells us where we put our y-intercept. Our y-intercept is going to be right here at 0. 4 is our average rate of change. And like any whole number, it can be written over 1. So it's really telling us that we're going to go up 4 and to the right 1. That's our new point. And I can connect the graph. Next, I have letter B, where we multiply negative 1 times our function. We're going to go ahead and distribute that negative 1. Negative 1 times negative 1/3 is positive 1/3 x, and negative 1 times 1 is negative 1. So that's telling us where to start. Negative 1 is where we put our y-intercept. And then our rise over run is up 1 to the right 3. There's our dot. Connect it. Whoops, that's not a beautiful line. That's a beautiful line. And that's it. Let me know if you have any questions. Otherwise, have a wonderful rest of your day. Bye.